Hello, this is Shiksha Vinay and I am going to teach you the kinematics part 6. Now, in this lecture, I am giving you the idea of trigonometry. As you know, trigonometry, the spelling of trigonometry is Trigonometry. This is trigonometry. So, first of all, I give you some idea about what this word trigonometry actually means. This word consists of 3 different words. First is try. And the try word, which is from Greece, is derived from the Sanskrit root we call 3, and the meaning of and the English person or Britishers, they tackle the word and modified it and they call it 3. That means the 3 word goes to Greece, it becomes try, and the try goes to Europeans and it becomes 3. And in Hindi it is known as teen. Have you got my point? And now gono, G-O-N-O, gono word is derived from the Greek word which is known as gonia. Can be written in the Greek word as gonia. This is a purely Greek word, and it means in English side, and in Sanskrit or Hindi it is known as bhuja. Now the third word is metri, which is also derived from the Greek word which is called matron. And here again, this word matron is actually derived from the Sanskrit word called matra. And this Sanskrit word, which also means in Hindi map, or in English it is nothing but measurement. Are you clear? So this is the meaning of the word trigonometry. Trigonometry is the branch of mathematics in which we deal about the measurement of sides of triangles, and by the relation of it we express all the mathematical problems with the help of it. So this is the branch of mathematics in which we view a triangle in a new way, new perspectives. So this is a new branch of mathematics. It is easier to handle than algebra, and you can see now how trigonometry works. So basically, trigonometry evolved from the problem of solving triangles or triangular relationship, such that how you find height of tree, how you measure the distance of Earth and the Sun, how you measure the distance between two stars, and this kind of trigonometry is perhaps discovered in India, in ancient India, but in printed report we can see at the first time in the work of Aryabhat. Aryabhat, which was one of the greatest mathematician or astronomer of India, who gave various path-breaking discoveries in mathematics. They wrote several books, but two books are now discovered. One is Aryabhatiam, or second is Siddhant Kaumudi. In Aryabhatiam, you can see the work of Aryabhatta in various areas like algebra or quadratic equations or real numbers, trigonometry, and so on, sequential series, binomial, and so on. So now here if you want to study the Aryabhat work, you can contact Shiksha Vinay, and here the book is available. And if you want to help, or you face difficulty to solve the problems of Aryabhat, you can contact the authority of Shiksha Vinay. Okay. Aryabhat discussed many things we will study ahead. And now the second name is Bhaskaracharya II, who was also one of the greatest mathematician of all time from India. Bhaskaracharya II wrote a famous book, popular book among mathematicians, called Lilavati, and actually the Lilavati is the name of daughter, and he wrote this book as a very elegant way. In this book, he wrote as a conversation between his daughter and himself. So a daughter asked question of mathematical question to his father, and father gave the answer. In this book, he also described many things about trigonometry and various algebra and other topics in mathematics. So if you want to discover the Bhaskaracharya and Aryabhatta, you can meet at Shiksha Vinay, or mail me or comment on the YouTube channel, my YouTube channel. Okay. Perhaps it seems that that trigonometry is discovered in India and then reached to Arab, and then after that it go to the Greece world, and now then when Englishman pervades all the world on earth, then they know about the trigonometry, and they discovered another more important terms in trigonometry. For example, Aryabhatta discovered sine theta and cos theta. And Bhaskaracharya discovered various values for sine, cos, tan. For example, he discovered sine 80 degree, cos 80 degree, or sine 36 degree, and so on. You will study about it in 11th class, so I am not dealing this kind of things here. And another important trigonometric ratio, which is also known as tan theta or cot theta, like that, is discovered by Europeans and British English mathematician, and also Greece. So this is the history about the trigonometry. Now our first topic is how trigonometry evolved. Why it is needed that a mathematician discovered it. It is obvious, because you want to find some distances, or you want to find large distance or height by some mathematics. You don't want to go there and then measure everything, then you find the real answer. You can do here in your room, at your study table, here and now. So mathematicians do their work, and they discovered many things in trigonometry. First of all, they encountered the problem that how the height of the tree is measured. And the second question, they encountered how we measure the distance of Earth, between the distance of Earth and the Sun. And also they encountered the problem how we measure the distance between planets like Mars to Earth or Mars to Mercury, etc. So this kind of problem always is a very exciting for mathematician, for ancient mathematician. So obviously, if you want to measure something, if you want to measure the height of tree, you have to tie a rope. So you join an imaginary line AC or tie a rope from A to C. Here you can see a person want to tie from this to this. And now you can see here this line AC is the greatest. Why this line AC is the greatest? Actually, it is given by the Pythagoras or Silva Sutra, and that say that in a right angle triangle, longest side must be the opposite to the right angle. It is obvious. Means this side must be the longest. Yes or not? This is Silva Sutra. Means the square of perpendicular plus a square of base, or a square of sum of a square of two sides, which is equal to the square of largest side. This is the Silva Sutra or Pythagoras theorem. That's why the AC is longest. Now in Greece, they want to measure the height of pyramid, so they use the rope, and the longest rope is called in Greece Hypotenuse or Tenuse, or Tenus. Hypo means, here you can see, hypo means very large or large. Tenus means thread. So the longest thread is called hypotenuse. Now in modern times we take this term in mathematics, and we say that the longest side of the triangle in a right angle triangle is called hypotenuse, as denoted by small h. Have you got my point? It means this is small h. So but in India, they tackle the problem of tree, mountain, stars, etc. on the paper without using thread or without having measurement. So they are in ancient time they are smarter than Greece, and so they can measure the height or something on the paper alone. So first of all, when we want to measure the height of a tree, and there is a viewing perspectives, how we view the tree. If somebody is at the top, here at the top of the tree, they can view this point through this line. And if a body is on the ground, then he can view the top of the tree along this line. This is our perspective. But a boy, if a boy is here and they want to watch the top of the tree or that point, this is undefined or meaningless. Why? Because they are at the place which connects both the direction, which connects two lines, and a direction have only one line, because if you see in one line, then it means it has a fixed direction. Or if you take two lines at the same time, it means it has two directions at the same time, which is seems to be impossible. So perspective must be taken from here and here, not from here, which makes right angle triangle. Have you got my point? So if you see is from here, your perspective is along this line. So in mathematics we can say that theta is gives the perspective or viewing, how you view. Means if an angle can also give the idea of direction or viewing perspectives. So here theta is can give the perspective of watching top of the tree. And now if somebody view from the top of the tree to the bottom on the ground at some point, and the perspective can be given by some angle, maybe theta, maybe alpha. It depends on reference line how we measure the angle. If you measure the angle from this reference line, it means your perspective can be given by, or direction can be given by theta. Or if you measure the angle from this line, this height of the tree, then the perspective can be given by alpha, which denotes the same line, same direction. So both the angles can give the same angle, same answer, same effect, same result, but here reference line is different. It is up to you. Okay. So alpha can also be taken for direction. Both alpha and theta gives the same direction, but in a different way. All angles in physics is measured with a reference line, as I already told you. So generally the reference line is taken as horizontal line. Means the x-axis, this x-axis, horizontal line or parallel line to the ground, is taken as the reference line from which we measure any angle. Have you got my point? Generally. Okay. Now we need to know about direction more, so I give you some idea about what is the meaning of direction in science or physics, mainly in physics or mathematics. So direction can be shown by various ways. It can be denoted by positive, negative. If it is taken along a line, it can be denoted by positive, negative. I told you in the previous lectures. So here is an example. If some velocity is in this direction 2 meters per second, it can be denoted by v1 vector equal to -3 meter per second, or v2 vector is equal to +2 meter per second, taking this direction as positive and this direction as negative. So biangle with a reference line. Second is biangle with a reference line. Means you can give the direction or idea of direction by the perspective or viewing perspective or angle with a reference line. Here, if I say the theta is the angle here, it means somebody view from this line. If I say alpha is angle here, we can say the from A somebody view along this line. So we can say the direction in a different way by angle also. Okay, here for alpha reference line is AB and for theta reference line is BC. Now we have already know that we generally use the Cartesian coordinate system for the direction, for the idea of direction. Here north is taken as positive and south is taken as negative, and east is taken as positive and west is taken as negative. Here is the origin where we take from all the measurement is measured from this point, where both the lines horizontal and vertical meet. So angle is measured by this east-west line always, or actually angle is measured by only positive east direction, not negative, means east direction. Generally in nearly all the cases we measure all the angles from this line. Have you got my point? Okay, so we assign a vector in each direction so that it is easy to understand the idea of direction. So we assign some vector for the direction. Now we assign, or mathematician assign, the direction. For the direction there are three vectors: I cap, j cap, k cap. All are small. Cap denotes, because it gives the direction, so its symbol is somewhat different from usual vectors. You denote arrow on its head, but here there is a cap, because it has a special task. It gives only direction. But you know, every physical quantity has some magnitude as well as direction. So if it has direction, it must have magnitude, because every physical quantity have magnitude. But if you want to only assign the direction, so what would be the magnitude of these vectors? If you only take the task of direction from these vectors, so what would the magnitude of these vectors? What do you think? Think about it. Can you assign the value of these vectors as 0 or -1 or 1, 2, 5, 9? Which is suitable? Because I have to take the work from this vector as only direction. It doesn't change the magnitude of those vectors, of another vectors. It only gives the idea of direction of another vectors. So in common sense, I have say its magnitude must be 1. Think about it. Now there are three vectors I, j, cap. What do you mean by I cap, j cap, k cap? So here I cap denotes the direction along the positive x-axis, or you can say eastward or rightward. Means here is the eastward direction, and so this is I cap. Similarly, you can say in the westward it becomes minus I cap, and in the north-south direction it is given by j cap, and so similarly minus j cap. It only gives the j cap means north or upward, and minus j cap means only downward or negative y-axis, or you can say south. Okay, there is a third k cap, is actually denote for the direction of 3D figure. not for 2D. For 2D we only assign two vectors I cap j cap, but for 3D we assign three vectors I cap j cap and k cap. And what is a k cap? K cap must have a line which on which it indicates the direction. Here is a line. I have given you a glimpse. This is in 3D, yes or not? This is in 3D. So this point, the marker point, is towards me. That's why it is positive z axis. And if we go towards into the paper, it gives the idea of negative z axis. Have you got my point? So negative z axis is denoted by minus k cap, and positive axis is denoted by plus k cap or k cap. That is the meaning of I cap, j cap, k cap. We will study about it further, but now I stop the dealing about direction. Now I go to the I will in the next lecture I will go to the trigonometry, and we will see there. Thank you.